4.4 part 5 is going to be used graphing y equals a sine of b times x minus c and y equals a cosine of b times x minus c. Alright, so first I want you to take note of how it's written. Our b is still with x, but it's not directly inside the parentheses with x. Sometimes they write it with b inside, and if it's inside with x, you need to common factor it out in order for this method to work. Alright, so why would we use this method instead of just doing what we've been doing with our table? Well, sometimes trig functions get a little bit tricky with all those pi's and pi's over 2's and pi's over 6's and everything else when we're dealing with our x value. So this is an easier way, I think, to build our x part of our table. Our y values, we're going to do exactly what we've been doing before, but our x, if I have a b and a c, I change it up just a little bit here. Alright, so the steps to do this, or the first thing we're going to do is we're going to find our amplitude, our period, and our phase shift. So remember, you find your amplitude by taking the absolute value of that a value. Your period is 2 pi over b, and your phase shift is your c value. Alright, so first thing you need to do then is identify a, b, and c so you can find your amplitude, your period, and your phase shift. Now, that means that our complete cycle is going to start at our phase shift and it's going to end at our phase shift plus our period. And so then we're going to find our 5 key points. So what we know then is that our first point is our phase shift, and our last point here is our phase shift plus our period. And then just like I do when I set up the parent table, how I go over it with y'all to help y'all try to memorize it, we're going to do the same thing here. So we're going to take that last value, that c plus 2 pi over b, and we're going to, well, we're not actually taking that. Let me restate that. We're going to find the distance between those two, and we're going to divide it by 2, and that's going to be our middle point here. And then we're going to find the distance between these two to find that middle point, and the distance between these two to find this middle point. So we're going to break it up into those intervals like what we've been doing. So that would do our x values, and then remember our y values we're going to do like what we've been doing. We would multiply by a and then add our d value. Alright, so let's try that here in example 1. Okay, so in example 1 it tells us to graph y equals negative cosine of 2 times x plus pi over 2 over a 1 period interval. First thing is check the form that it's written in. Is your b not directly inside the parentheses beside the x? This one's not. So we can use the method that we just talked about. If it was inside with x, I would divide both of those, the x and the c value there, by 2 so that I could common factor it out. Alright, so let's go through. First thing I'm going to do is identify my a, my b, and my c, and I'd identify a d if I had it. Alright, so my a is a negative 1, which means my amplitude, remember that's the absolute value of a, so it would be 1. My period is 2, which tells me my b is 2, which tells me my period is 2 pi over b.
Ladies and gentlemen, please check to make...
Sorry about that. So it's 2 pi over b, which in this case our b value we said was 2, which means my period is pi. And then my c value is positive pi over 2, which we know that means for our, I'm just going to go ahead and write it this way, our phase shift. Because it's positive, we're going to go to the left, pi over 2. Alright, so what would this look like in our table? So for our table here, for my x values, I'm going to start at my c value. So we go left pi over 2, it's a negative pi over 2. And then, because that's my c, and then remember our last value is c plus the 2 pi over b. And so that means it's going to be the negative pi over 2 plus pi. So when I add those together, I get a positive pi over 2. So now all I have to do is find the intervals. So what number is halfway between negative pi over 2 and pi over 2? Well, if you don't know offhand, that's okay. Take those two numbers, add them together, and divide it by 2. So if you're using your calculator, you would take negative 1/2 plus 1/2 divided by 2, and then put pi back on top. What happens to be when you do this one, you just get 0. And so if I want to find the value that's in between negative pi over 2 and 0, I would add those together. So negative pi over 2 plus 0 divided by 2. So in my calculator, I would put negative 1/2 plus 0, which is a negative 1/2, divided by 2, and you should get negative 1/4, so I know it's going to be negative pi over 4. And then I'm also looking for the value that's in between 0, halfway between 0 and pi over 2. So I could do the same thing, do it down here at the bottom, 0 plus pi over 2, divide it all by 2, and it's going to give me a positive pi over 4. So now that I've got my x values, I can find my y values doing what I did before. And the only thing we have that's going to affect the y value is that a, which is a negative 1. So we're just going to multiply our y's by negative 1. Now in order to do this though, you've got to remember what the parent table is for cosine. And I probably should have written that already, so I'm just going to come up here and I'm going to write it real small because I need to see it. And so I know cosine is a period from 0 to 2 pi, the parent function. So pi is halfway, and then halfway between each of those small intervals. Cosine starts at the top and goes down and then comes back up. Okay, so remember, this is our parent table. So I'm going to take those y values and multiply them by negative 1. So the first one, 1 times negative 1, 0 times negative 1, 1 times negative 1, I'm sorry, negative 1 times negative 1, 0 times negative 1, and 1 times negative 1. And so there's my new table, and I can graph that. Alright, so let's pick our scale. Pi. Alright, so make sure you label the scale so I know what you're using. And then plot your points. So negative pi over 2, negative 1, pi over 2, I'm sorry, negative pi over 4, 0, 0, 1, pi over 4, 0, and pi over 2, negative 1. So that is one full period of my graph.